Hello guys, today is unit 14 of our training Java programming, Intro to Java programming, Intro to Java EE programming 2. My name is Yakov Fain, I'm with Farata Systems. The topic for today is overview of Java Enterprise Edition, and we'll start dealing with Java Servlets. What is Java EE in general? What is JCP? What is JSR? These are the terms that are familiar to most of the Java professionals. How Java gets evolved, so to speak. People around the world decide that some new feature probably may need to be introduced in Java. Maybe some new technology, maybe some new workflow of how to process data, how to write programs, how to distribute the application between different servers. And this whole thing is the whole thing of developing standards for Java is called JCP, or Java Community Process. Actually somebody decided to give a proposal. I would like to make a spec to send messages from one application to the other in Java. I can write a proposal, and it's called Java specification request, JSR, that I want this technology, messaging, and this is how I see it. Then, if this makes sense, if people believe that what I wrote makes sense, then a group of experts is created as an expert committee for this particular JSR, this particular request. This JSR is giving a number, and then this committee publishes all these different versions of all these different editions, revisions of this JSR until it gets to final. If it gets to final, then somebody has to create a reference implementation of this idea. In my example of the messaging, for example. Then there is something called Java EE. Java EE is a collection of such JSRs. So maybe 30, 40 JSRs are grouped together, and it is announced that Java EE 6 or Java EE 7 is released. Java EE 7, for example, is also a JSR. It's JSR 342, but it includes other JSRs. So if you are saying that I know how to work with all Java technologies from Java EE 7, you are technically saying that I know how to work with all different technologies listed in or included in Java EE 7. Actually, it's 342. It's a mistake on the slide. It's 342. And JSR shows or describes every little detail of the process of how to use this particular Java technology. In case of Java EE, it includes all other JSRs that should be included there. So this is a diagram that I took from the specification itself, and it says, for example, if you want, you can use web container. Web container is a place where on the server side you write code that communicates to the client, say to the web browser. What can you put in the web container? The specification says at least all these cryptic words or acronym, and it says that still you need to have Java SE, but on top of Java SE you need to have implementation of all these different things, like for example CDI, JCC, web services, JTA, JSP, and so on. Then they say you should have an EJB container. What's EJB? Enterprise Java Beans. And the container is where these beans live. You can write business logic in special classes that are called EJBs. So again, you have Java SE. On top of that, you have EJB container, and it's supposed to, this business tier, supposed to support all these other JSRs. Right? Or they say you can have the application client container. This is basically, it's not a part of the It may not be a part of the Java EE, but it still shows you the way to architect the application, and so on. Now, let's look at a sample of how you can architect a distributed application when you have something running on the client and some code is running on the server. And it may not be running on the same machine, in the same JVM, it may be distributed. Typically, when you write code, you try to split it into manageable portion, and we try to split it into portion based on the use of this code, based on the goal for this code. For example, you can write code just for the client. It may be in Java, it may not be in Java. It may be HTML, JavaScript, for example. But in that case, you would have a client running in a browser, in a web browser. This client in a web browser could communicate to the server, with the server, different ways. But it's still, this piece of your application belongs to the client tier. So your application may have multiple tiers. Or you may want to develop a client in standalone Java application, or maybe a standalone JavaFX application, maybe with using Spring. But for that you need nothing but a Java runtime. Java runtime on the desktop can start it. And it also can connect to the server side, if any. As a matter of fact, you can write a standalone Java application that doesn't need any servers, right? You can write a game, for example. It doesn't connect to anything. But the point is, what I'm trying to deliver, you have some code that belongs or can be qualified as a client tier code. Client meaning on your client computer. And again, even if you write independent Java application, you can still communicate using different technologies, maybe protocols, maybe APIs with the server side. Let's talk about the server side. Say you have a web application. When you have a web application, there is some code on the server that is like a doorman, so to speak, that talks to your client. The client, it's like a first line of, it's not defense obviously, but it's like the first communication point, the first contact point for the client. This is called presentation tier. This tier is responsible for sending the data to the client to be presented there. How it sends the data, we'll talk a bit later, but there are specific technologies that are supposed to be running for the web application in the presentation tier, in so-called servlet containers, it could be done, or in a, and it has to have a web server. And these technologies are, again, this is not a complete list, but some of them. Servlet, you could use Java Server Pages, you could use Java Server Faces, JSF. Then you can create so-called RESTful web services, or maybe you can create SOAP web services. So there are different ways to arrange this presentation tier. But the point, the keyword over here is the word presentation. This tier typically does not have the code that implements your business logic. It may be, like, as I said, like an endpoint, a doorman, a door through which you can go to a different tier, a place where you implement business logic. In the Java EE architecture, they prescribe you to use EJB container and put the object there. It's not like they force you to do it. You can say, you know what, I don't need all these EJBs. I'm pretty happy with this tier. Presentation tier will have some classes that will communicate with the client only, but I also want to include a package with business code. It's also possible. You can deploy just the web application that is, but still you can logically split it into two parts. A part that is responsible for the presentation and the part that is responsible for the business. But let's talk about the classical split, so to speak, in the Java EE world. I want to stress, I'm talking about Java EE. It's not the only way to create the server-side application. There are different popular frameworks that are saying we don't like all these EJB containers, we don't want Java EE, that's fine. The most popular framework is Spring framework, which also consists of a bunch of modules. But they say, if you want to use Spring, you don't even need Java EE. But again, it's not the topic of our lesson. It's not our concern today. So EJBs are the recommended way to write business logic. The business logic is a process of implementing some business rules, but you need to persist data. You need to work with data. You need to retrieve data. So where, how? And now we are talking about the data tier. Where do you store the data? Maybe you store them in the database management system, maybe in RDBMS, relational database management system. And we studied how to use JDBC. Maybe you don't want relational database management system. Some people are using not JDBC, not RDBMS, but they use NoSQL. So maybe you want to store data there. Maybe you don't even want to store data in the traditional database. Maybe you just have messaging server, and you are for persistence you are sending messages using JMS API, Java Messaging Service API, which is also part of Java EE. And to get data from the data storage, you don't even know where it is. You are asking messaging server. You are reading messages from messaging server, which will probably send you the data based on maybe your request. Maybe the messaging server decides to push the data to you without you requesting. Maybe you have an external system not even written in Java. Maybe it's a mainframe application written in COBOL. That's fine. You can connect to it using so-called JCA standard architecture. JCA, Java Connection API, or Java Connectors API, I believe. It allows you to create adapters to communicate with other systems which are not Java. So this diagram shows you an example of multiple tiers. For now, just remember that they are there, and which one of these you're going to be using, it's up to you, or maybe up to your team lead, or maybe up to your enterprise architect, or maybe up to your best friend in your little small startup. This slide says Java E7 major edition, as if you know what was there before. You know nothing or not much about Java EE yet, right? I assume that. No offense. But before Java E7 was what? You guessed it right. It was Java E6. Java E6 was released probably like 3.5 years ago, maybe even 4. But Java E7 was released I believe in May of 2013. When I say Java E7 was released, what does it mean? It means that the specification was released. The final version of what is known today as Java E7 was released and published on May of 2013, about a year ago. All right, you published a specification. It's very good, of course, but can I try it? Can I play with it? Is there any server that supports all the technologies that are included in Java E7? And the good news is yes. And the company called Oracle, that is a leader of everything Java related, of the Java evolution, not the only company, but a leader in the Java community process. And they also release a server that is called GlassFish, and every new version of the server is, no, this is not the right way to put it. If Java EE specification is released, a new version, then you can expect GlassFish application server to be released that implements this specification. So GlassFish 4, version 4, for example, is a reference implementation of Java E7. It fully implements all the features that were defined in the spec. And we can say that GlassFish is a Java EE compliant application server. Not the only one. Eventually, more and more vendors start to implement Java EE7 spec, and then they say our server version so and so implement Java E7 as well. Still, let's talk about some additions. Even though you don't know what was in Java E6, at least you will know what did they try to improve. Actually, the major, I didn't put it as a bullet over here on this slide, but the major area of improvements for Java E7 was web clients, HTML5 and related technology. In particular, they added API, standard API to process JSON. JSON is a data format which can be used in particular for sending data between web clients like JavaScript and the server like Java. It's not specific to Java technology, but JSON is a data format. Like XML is a data format that can be used in different languages, different technologies, and on the same note, JSON is a data format. We are not covering JSON in this course. There's another course that our company runs for other systems. It's called Modern Web Development for Java Developers. That training is covering a lot more, but it expects you to know basics of Java already. WebSocket support. It's also from the area where the web client talks to the server. Again, not only, but mainly. If you remember, in one of the lessons in this course, we've been studying sockets, raw sockets. But this is specific way of working between a web client and web servers. Next, multi-threading. We've studied multi-threading, and now in this specification, they allow to use multi-threading in Java EE container as well. You can say, how come? Didn't they use multi-threading before in all these server-side technologies? They did, but they said if you are running your code inside the EJB container, for example, you're not allowed to create your own threads. Container will take care of multi-threading. Now they eased this restriction. Messaging, they made some changes to simplified messaging, and so on. So the tutorial of Java E7 is right there. It's Oracle published tutorial online, available for everybody, free of charge. Every technology is described in there, and I highly recommend you to go there and study there, because our course, my course, 1 hour, 2 hours, 3 hours is not enough, definitely. So which servers support today Java EE? If we talk about the previous version, Java E6, 18 servers, 18 different vendors already released servers that supports Java E6. But Java E6, as I said, about 4 years old already. What about Java E7? As of May of 2013, there are 2 servers that fully support the spec Java E7. GlassFish from Oracle and Wildfly from Red Hat. Wildfly used to be called JBoss server. They rebranded it a year or 2 ago, and this is how they call it now, but it's technically JBoss. If you want to check the current data, who is supporting Java E7 spec, which server supports, follows this link and you will find the latest and greatest data about support. We are going to use in this course GlassFish. In the other course that we teach, we use Wildfly. But in this way, we are using GlassFish from Oracle. And your first goal for today, it would be to install GlassFish. The good news is that it's very, very easy. You just go to this website, glassfishjava.net, and download HTML. And download GlassFish 4.0. At the time of this writing, it's 4.0. Maybe when you will be doing your download, it'll be 4.1 or 2 or 3, I don't know. But just download that zip. They call it quick start also. And unzip it somewhere on your disk. Unzip it into a directory, like I did on mine. Where is mine? It's over here. See, GlassFish 4 is the name of the directory where the GlassFish zip is unzipped. Inside of that directory, you can find other directories. One of them is called GlassFish. Please note the difference. The main one, the outermost, is called GlassFish 4, but it contains the directory GlassFish, which is important to understand when you will be configuring your Eclipse working with the GlassFish. It's important to point at this internal GlassFish directory. It also has JavaDB. Remember, we were studying DerbyDB. We've been using it in the JDBC lesson. GlassFish happened to be packaged with this JavaDB as well. GlassFish also include another product called OpenMQ. It's an open source product for support of the messaging. So GlassFish has most of the code written specifically to implement Java E7 plus. They include a couple of packages that are easy to use with GlassFish and can demonstrate you see some other technologies. So you unzipped this folder, this zip file, sorry, and now you need to go there. You need to go open up command window, or if you're on Mac or Unix terminal window, and go to the bin directory in that folder. If you open up this bin directory, you'll see that there is a special ASAdmin. It's a special tool that allows you to start the server, stop the server, and something else. So let's do it. Let's do it over here. But my goal is I want you to start the server. In this example, this is a command that you need to run on your command line. On your command line, if you are on Unix or on Mac. If you would be on Windows, it's still the same command, but without this // without this // and also it's not just ASAdmin, it's an ASAdmin but. It's a script file. So let me go to my terminal window. All right, so this is my guy. cd GlassFish 4. What we have inside, all this stuff, right? cd bin directory. What do we have in there? ASAdmin. So this is what I want to run. See this? ASAdmin. I want to start the domain. GlassFish has this concept of domains. You start the server, and in the server you start so-called domain. You can have more than one domain that you can start within the same server. By default, they have this domain called domain 1. When you just unzip the GlassFish, domain 1 is already pre-configured, and we have no reason not to use it. So let's do it. It's domain 1. This is the name of the domain. See, it's starting. GlassFish is starting now, and when it's ready, it's going to be listening to your request on the port 8080. Beside that, it prints over here that admin port is 4848. So the port 8080 is a port which you should be using if your clients needs to access some code that is running on GlassFish on the server, and the port 4848 is the one that administrators will be using to configure objects inside GlassFish. Okay, so this slide is done. Next, we want to see, and we want to make sure that the server is up and running. How to do something like this? Just go to the browser and enter localhost 8080, HTTP of course, or here HTTP, and the server responds. See, this is a GlassFish page. It responded. It says that it's running. Very good. So this is the proof that it's running. Let's see what is on the port 4848. This is the GlassFish console. GlassFish console can show you the objects that are deployed inside the server and exist there. Again, this is for administration of the objects within the server. This is a console. Later, not today, but on the other lessons, we will see something. We will look at some objects that live there. In particular, see this node JDBC. This is a place where you could have created JDBC resources. Remember, I was talking that in the lessons on JDBC, I was telling you that there is something called data source. So you can get a database driver, JDBC driver, and configure a data source that will run in the server, and it'll include connection pools as well, right? Maybe you want to create a Derby pool, right? If you are running DerbyDB, and look at this, maximum pool size 32, minimum 8, configurable, of course. So you may have from 8 to up to 32 connections to the database servers that run at the same time. So anyway, so this is a console of the GlassFish server, and on the port 8080, it's a place which listens to HTTP request. It's a web server that comes with GlassFish server. It's your entry door for HTTP requests. It's up and running. Now let me kill it. I'll go back to this command line, but instead of start domain, I'll do stop domain 1. See, I killed it now. If I'll go back to the browser and refresh the page, you will see that there's nobody there. The server will stop responding. Oops. Of course, oops, because there's nobody on the port 8080. We just killed it. So I just started and stopped the server, which means I'm done with the walkthrough number 1. If you want to read a bit more about how to do start and stop, load this document, this PDF, and read up over there. Next, we will start talking about one of the technologies that is a part of Java EE for many, many years, not only 7, but from day 1, I believe. It's called Java Servlets. And this is a technology that Java developers use for communications with web clients, web browsers. It's not the only one, but it's probably the main one. Web browser. Say you have a web application, HTML, JavaScript, CSS, everything is running in the client's web browser. If you fill out the form and you want to find something on the server side, say you want to find a book on certain criteria, you go to Amazon.com or any other online store and you enter some criteria and press the button search. What happens after? After that, web browser creates an HTTP request. This is an object that is has a special form. It has a header, it has a body, and it encapsulate your request. So the browser knows I need to send this request at this particular URL that was on the page. Maybe it was a link, maybe it was a form, regardless. When the web server, which is the first doorman, as I said, on the server side on that URL, returns your response, returns the web browser response. It comes back in the form of HTTP response. It's also a package with several hundred bytes, and among all this extra overhead, you will find your data in there that you requested. Maybe the book was found based on your criteria. And if this would be a world with static content only, say every request that the browser make was every resource or the page that the browser wanted to see was pre-created on the web server, then everything would be static, nothing would be created on the fly, ad hoc. Then we don't need anything else. We don't need any servlet container, any other technologies. Then web server would be qualified to return you back all the requests. Web servers can return only static stuff. Say a file that exists there, maybe an image, maybe a video, but not something that's supposed to be created or generated on the fly. If the web server cannot do that, for example, a request comes in which requires maybe to do some Java code which will connect to the database and will execute some query. Maybe this is what is required. And of course, if you are talking about the online store, there is no way to prepare the whole inventory. The separate files for each item in the inventory on the web server. Right? So the requests are being processed on the fly. So if web server sees that I cannot handle it on my own, this is not a static resource that they want, it repackages this HTTP request, in the Java world at least, into the HTTP servlet request and passes it over to servlet container, which is a presentation tier. Remember that slide with a multi-tier architecture. So the servlet container, we assume that there is some servlet, a Java program written in a special way that knows how to process your request. This HTTP servlet request finds your servlet. This servlet executes some Java code, maybe Java code which goes against the database, and it'll run the query, find me all the books where the title is, the title like love. Maybe you want to find all books that includes the word love in the title. If the result set comes back, it comes back to the Java program, which is Java, in this case my servlet. My servlet would form an HTTP servlet response package with the result set that you created and format it ready to presentation on the web. It includes HTML as well, maybe JavaScript as well, and it'll send it over to web server. Web server will take it, repackage it into HTTP response, and send it back to the browser. The browser receives HTTP response, which the browser knows how to deal with, how to render, how to display. The browser could care less if you are using Java technologies or .NET technologies. Maybe you write it on PHP, maybe on Python. The browser understands. I need to send HTTP request, and I need to react when HTTP response comes back. That's all it understands. The rest is up to you and up to your hosting company or department in your enterprise to arrange the server that knows all this routing between regular web server and your Java servlet container in this case. To use Java servlet, you don't have to have full-fledged Java EE application server. You just need something that implements this presentation tier. And the most popular servlet containers are Apache Tomcat and Jetty. These are by far the most popular ones. Some companies don't even bother implementing their application under Java EE servers. These servlet containers are good enough for them. But if you are considering using any Java EE application server that fully implements Java EE, then of course it'll come with its own servlet container. In some cases, some application server may even use the same Tomcat. For example, JBoss till the recent time was using Tomcat as in their package for implementation for Java EE. This slide, number 10, is going over in details. We are considering again the process of buying something in the online store. Imagine that you have an online store that is deployed on the website with the URL mybooks.com. So how the whole workflow can go. For example, the client sitting at home with his computer that has only web browser. His computer doesn't need to have anything else. He enters the URL mybooks.com, http://mybooks.com, and the home page of your store comes in. The bookstore consists of number of HTML pages. There's the main page. Say we have a search book. I enter the word love in there, press the button search, submit, and the browser, as I said before, creates a HTTP request and sends it over back to this mybooks.com. But it sends it over not just mybooks.com, it attaches something to the URL to specify that they want to search. Because search is not the only one. Maybe there is not a button that would say add to shopping cart. In that case, the other URL will go back to the mybooks.com that has a functionality to add the selected item to the shopping cart. So when mybooks.com receives this request, it has some web server in there. Web server starts to evaluate what do they want from me. Do they want a static page, such as terms and conditions? Then it would return back the static page. But no, this time they want to find something. They have a search criteria. So it understands that it's not a static content, and it passes this request over to the servlet container. And based on the URL, it'll find there's something called mapping of the URL to a particular servlet, because your servlet container may have multiple servlets, right? So you're doing some mapping, it'll find the right one that knows how to search, and after that, regular Java code works to the database, find the result set, create the HTML page. We are still on the server, right? And it needs to form it in a so-called HTTP servlet response. Send it back over. This response goes through the web browser, which converts it into HTTP response, and the user will see the result set. Then another HTML page that shows all the books that may have the word love in their title. Let's look at a very simple example of HTML page, which has header and a body. And in this case, it has also a tag called form. So this is an example. This form, has one text field. We call it book title. And it has a button submit with a label search. So the user can enter the criteria for finding a book and hit the button search. Whenever they hit the button of type submit in the form, it's an HTML rule, it goes to the actions attribute of the form. When you hit submit, the browser will try to contact whatever URL you placed in the action. It's the simplest way of sending the request. It could be more complicated. You may have a JavaScript name of the function over here, still on the client, that prepares a request. But in the simplest case, it's just an action with a URL. This URL in particular has something else after mybooks.com. It has the word servlet, and it has find books. One of the way to find the servlets. Then it says something else. Method equal get. HTTP standards has multiple methods which are the way to communicate with the server using HTTP protocol. Get, post, put, delete, head. What else? Options. So there are different ways. Most popular especially in the web applications that use servlets are get and post. The web applications that use RESTful services use get, post, put, delete. So anyway, this is how it works. Yeah, I hit submit, this URL went, and in particular it says I want browser to use method get to communicate the server. It's important to remember. So in walkthrough, it's a very simple one. I'm not going to be doing it. You will do it on your own. I am asking you to create a text file which called book search HTML with the content of this previous slide. Save it as a plain text. Go to your browser, do file open. You will see a little text field and the button submit or search. Enter anything, hit submit, nothing's going to happen. Why? Because you didn't implement the server yet. You didn't implement that URL, mybooks.com. It doesn't exist. But now let's see how to implement a Java servlet that can respond, or maybe that can process some requests. First of all, some theory, and then we'll go to Eclipse and we'll create the project, and we configure the GlassFish over there and everything. The theory. The theory says that there is a class called HTTP servlet. It comes with the Java E7. When I say it comes with, it means that whatever server you use that implements, that includes servlet container, is supposed to have a jar file. Remember, libraries, jars. That jar file will include all files required for servlets, one of them being HTTP servlet. So that jar file must be in the class path of your application, of course. So you create a class in a special way and you will annotate it. Remember annotation? You will see a lot of annotations in the Java EE world. So you'll annotate it with the annotation called @WebServlet. By the way, the class HTTP Servlet extends the class generic servlet, which includes one of the methods called service, the main one. So whenever the web browser sends a request, HTTP request, to the server, and it requires servlet, the servless service method gets hit first in the generic servlet. Then it looks at the subclass. Say you created your servlet. That is a subclass of HTTP servlet, which is a subclass of generic servlet. So the code inside the method service will analyze immediately the method. This method. How they want me to proceed? Oh, they want get. They send me the data, the parameters using the get request. So what this service method will do, it'll invoke doGet from the subclass, from your servlet. So technically you are overriding doGet. That was in the generic servlet. I don't remember if it was in the generic servlet, but definitely it was in the HTTP servlet class. Apparently it was there as well. So just because you said that the method is get on the HTTP protocol, on the HTML page, then the doGet is invoked. If that page would have method equal post, then doPost would be invoked on the servlet. So when you write a servlet, you need to decide where do I put the code to process request. If you expect the client to send you the request using get method, then put it in doGet. If post, put it in doPost, and so on. And the servlet may look like this. Up on top, all these different import files. And of course, again, these, the first one are sitting inside the jar file that supports Servlets API. The class that I am showing you over here is called FindBooks. This is how I decided to call it, but it is annotated with @WebServlet annotation. This is what makes it a servlet. What else is interesting in here? It has a URL pattern. It says, if the URL will include /books as a part of the URL that comes from the browser, then the FindBooks should be invoked. This is an instruction for the servlet container. This is how the routing is done. So the servlet container may be running a bunch of different servlets, right? But when this servlet was deployed inside the servlet container knows if anything includes /book or books in this case, then I need to redirect this request to the servlet called FindBooks because it knows how to deal with this kind of requests. And this is the name of the servlet, just the name. So in this case, we are expecting requests to come using the method get. That's why we put the code inside the doGet method. doGet method, as well as doPost, by the way, will come with two arguments. One of them is for getting HTTP servlet request in. That's a link between the servlet and the specific client, specific browser. And the second argument is to send back data to the client. So this request is coming in. Response is the way for your servlet to send data back to the client. And these two are given to you by the container. It's a callback, doGet. You never call it yourself, but you just write the code in there, assuming that when the request comes in, then the doGet is called. So in there you do whatever you like, any business logic, and eventually say you found the data that you want to send back to the client. So you are saying to your response to this parameter, give me the reference to your writer. Remember the IO streams? And you will be right into that stream. In this particular case, the stream points at the user, at the browser where the user sent request from. And then you say out println into this response, hello from Filebooks. Of course, it could be much more advanced or a comprehensive response. It could be the entire HTML page over here. So the browser would see the HTML page with the search results. And how do you deploy a servlet? Where do you put it? Okay, you compile it. So what's next? What's the structure of the directories? Where to copy it? How the server will know that I have a servlet? As I said, first of all, of course, you specify the annotation, you specify parameters in there, but as far as directories goes, there is something called document root. I believe I mentioned that before in one of the lessons when we spoke about applets, right? We discussed applet. The document root is a place where you put HTML files, maybe images, static content, JavaScript. But underneath, in the Java world, there are a couple of directories. One of them is called web.inf. The other one is called meta.inf. Web.inf is mandatory if you're writing servlets. So your compiled servlets will go there. I'll show you the structure of this directory in greater detail. But for now, I want to reiterate. There is something called document root, which can be different for every application server, for every server container. You need to read the documentation for the server that you will select, and you will find out what is the document root directory for this particular server. And this is how you know where to put your HTML file and stuff. So, for example, on GlassFish, this is a document root. If you'd be using Tomcat servlet container, web apps is the document root. So whatever you will enter, so your servlet will go under the document root and further down under web.inf. Here's the structure, sample structure of the web module. So document root, as I said, then you put HTML pages, then you have a directory web.inf. Under the directory you have, under this one you have two, or you may have two. One of them is classes, where you can deploy your servlets as they are. For example, in this case, compiled class find books goes, apparently it was in the package com practical Java lesson 27. That's why it's sitting in all these subdirectories. It's not that typical to deploy compiled classes separately. Why? Because only in very simple applications you will have one or two classes. What if you have a bunch of them? Then you would be putting them in a jar, which would be sitting inside the lib directory. Then there could be a file called web.xml. It's an optional file, configuration file for the servlet. In the past, it was the only one to configure a servlet. Now most of the configuration is done, or actually, I would say all of the configuration can be done without web.xml, using annotations inside your Java class. But it's still there. The folder meta.inf may or may not be there, it's optional. It may have some useful configuration parameters. Some maybe databases prescribe you to put configuration of the database in there under the meta.inf. Maybe something else is there. But again, meta.inf may or may not be there. And when you compile the servlet, then it plays either as a class, or maybe you build a jar. In any case, you need to have a structure like this, and this structure typically you deploy as one file, which is called web archive or WAR file, a file with extension WAR. And these WAR files, they actually have the same structure as zip files or as jar files, but this is how we typically do this. Do deployment of the servlet. Everything inside the WAR file. Not only the servlets. It could be servlets, Java server pages. You could use REST web services. All of that is packaged in one WAR file and is deployed under a certain servlet container or Java EE application. Typically, we in a real world, usually we write build scripts that would create such a WAR file. In the simplest case, you can create a WAR file using your IDE. You can create a project in Eclipse in a special way, dynamic web project, right click on it, and there will be an option export to WAR file. But again, in the real world, we prefer not to depend too much on the IDEs that you use, but the script should be able to compile everything and copy into the right place and zip it up into a WAR file with appropriate structure. Now let's do this walkthrough, which is how to start or configure GlassFish to be started or controlled or managed from within Eclipse. We are lazy, we don't even want to leave Eclipse IDE. We sit in there all day long. So in this case, I'll show you how to configure GlassFish so you can start it and stop it and deploy applications in there without leaving Eclipse. So first I said shut it down if it's still running. I already killed it, right? In my command line. Then you need to go to Eclipse, and you've been sitting so far in Java perspective all the time. Now switch to Java EE perspective. If you don't see it immediately, as I see on my toolbar, go to Window, Open Perspective, Other, and find it there. You'll find it somewhere there, over here. But I already have it open. So Java EE has just a little bit different set of views, but nothing major. Anyway, so we want to create a new server. We want to configure a new server. Actually you can go right away under the server view. I already have Tomcat from one of the past lessons, but I want to configure a new server GlassFish in there. Right click right in the middle, or you could have gone through the menu file, new server. Which one you want? I want GlassFish 4.0. Again, in the real life, if you'd be needing some other server and you don't see it in this list, there is a link, download additional server adapters. Go there and see, maybe you find it there. So if you don't see GlassFish 4.0, which you should, then click on this link and download it, and then it'll be in the list. So it's suggested, do you want to call it localhost? Well, let's not change it, doesn't matter. Do you want to use this as a server name? Again, it's only how it's going to be presented in the server we use. What is a server runtime environment? I already did configuration on my machine, that's why it knows already that where it is located. If you do it for the first time, you may see a screen like this. It'll ask you, show me the directory where your GlassFish is unzipped installed. So you need to point at this GlassFish. Again, reminder, not at the outer GlassFish 4, but inside there's a subdirectory GlassFish. Name it the way you want it, what JDK you want to use. At the time of this writing, there is a bug. Apparently it's a bug in the Eclipse that doesn't let me to specify Java 8 over here. It works fine with Java 7. So for our purposes, it doesn't matter. So maybe when you will be running this example or watching this lesson, maybe they already fixed this bug. At least I filed it with the GlassFish. Again, I don't want to blame them. Maybe it's not even their fault. So you need to specify where your GlassFish is. I already did this, so in my case it knows. Right, so then you will hit next. Don't change anything in the admin screen. Domain directory is your domain 1, default domain, right? Don't change anything there. Next. The next screen, it shows you, do you want to deploy some application, some projects? I have nothing to deploy. I have empty Eclipse workbench. So if I would have it on the left-hand side, projects that are available for deployment. I would hit the button Add. They would be moved to the right-hand side, and this is what deployment in GlassFish means in Eclipse. For now, just hit Finish. GlassFish is over there. Right-click. I can start it. Now it tries to start a GlassFish. See this console output? It's starting. It started now. See, it says started. Okay, it started, so it's ready for what? For nothing, because there's no application deployed in there. Of course, it's up and running. Even though I started it from Eclipse, you can still go to the web browser, do refresh, and it responds. It doesn't matter how you started. The point is that there is GlassFish server sitting and listening to the port 8080. Next. So this part is done, this slide. And now the next step is to write a servlet and deploy a servlet under GlassFish. That's our next goal. In Eclipse, there is something in Eclipse for Java EE developers. If you remember in the lesson 1, I specifically asked you, please install not a regular Eclipse, but Eclipse for Java EE developers. Now the time came, and you will understand why I was begging you to install this version. Because it's Java EE for Eclipse for Java EE developers comes stuffed with a bunch of plugins. One of them being WTP, Web Toolkit Project, I believe. The one that allows you to easily create web application, web project in particular, and it's called Dynamic Web Project. So you will go to menu file, new, and find Dynamic Web Project over there. File, new, Dynamic Web Project. If you don't see it right away, go through other and find it there. Give it a name, and I want you to name it specifically. What? Actually, we didn't even start the walkthrough. Let's start it now. I want you to name it lesson 27. I decided to name it this way. Lesson 27. Cool. Note that the target runtime says over here GlassFish. In my case, I have more than one target. I have Tomcat and GlassFish, right? But I don't want to do anything with Tomcat now. I want to work with GlassFish. So just make sure that you understand that this project, Dynamic Web Project, is created for deployment under GlassFish. Next. We don't change SRC. We don't change the location of the classes directory. Next. Context root. Context root, it is going to be a part of the URL for the browser. And context directory, where the code will go, where the document root is going to be, where the webinf you want to have. And Eclipse offers you, by default, this directory web content in the project specific to Eclipse. But we don't change anything there as well. So we got a new project, lesson 27. If you'll open it up, you'll see Java resources is a place where you will be writing your source code, Java classes, right? If you had JavaScript resources, maybe you have something, you would be placing them over there. Under build, you will have compile classes. Web content is technically your document root in Eclipse if you want to work with this, with any server from Eclipse. There are ways to reconfigure it, but let's not bother. So see, it's created for us two subfolders, one of them meta-nf, optional, and it created for us webinf. That's mandatory. Okay, so we are ready to create our first servlet. And let's read the instructions written by me. So we are on step 4 on this slide. So I'm saying create a new servlet in a particular package. I want you to create a servlet in a package com practical Java lesson 27. And I want you to call it findbooks. How would I do something like this? src, file, new. Where is servlet? Right there. Again, if you don't see it on the menu, go to other, servlet. Lesson 27 will be sitting in the src folder in the package proc copy paste problem practical Java. What's the name of the class? I want it to be findbooks. Okay, this servlet, it knows that automatically it should be extending HTTP servlet. Next. And I write it on the slide, and I want you to do this. See this step number 5. In the URL mapping, select Find Books, press Edit, and enter book. I want to change the mapping, basically. By default, it says if your servlet is called Find Books, the URL also should have Find Books in the URL. I want to show you how that you can change it. I want you to use the word book in there. So what does it mean? It means that if any URL that will be given by the browser to this server will contain this pattern, this word, then the container should pass the control to the servlet named Find Books. I change the mapping. On the next screen, it asks you, do you want me to generate for you do get and do post in this new servlet? Yeah, why not? Keep it there. Or maybe if you're not planning to do post, uncheck this do post, but I will not change anything. Finish. And as you can see, we have a new servlet. It's already annotated for us with a proper mapping. It's called Find Books extends servlet. That's fine. And it has do get, and it has do post. Each of these guys have two parameters: request, response, request, response. Getting stuff from the browser, sending stuff back to the browser's response. And of course, after line 29, it's a place where you have to put your business logic. You have to implement, sorry. So we saw that, and end. Step 7, I say, please do this. Get a reference to the writer of the response object and send over there a friendly message, hello from Find Books. And this is what we copy pasting from our slides. It's right there. And of course, it doesn't know who is the print writer, right? But we can ask Eclipse. We can ask Eclipse, command 1. Import for us, please, print writer from somewhere. I did that and it imported. No errors. So what does it mean? It means that whenever request comes to the servlet, it comes through do get, if the method was get, which is a default, by the way. Then we are just getting a reference to the output stream from the response, and over there we send our greeting, hello from Find Book or Find Books. Done. Now we need to deploy this servlet in the GlassFish. It's not deployed yet. So we created a project, we created the code, but GlassFish has no idea that when it starts, it's supposed to pick it up and deploy it in memory. So right-click, add and remove. This is our deployment, or again, removal from GlassFish. As you can see now, it understands that there is a project, lesson 27, that was specifically created for the target runtime GlassFish 4. So let's edit to the right and finish. So GlassFish restarts and synchronized, and it is deployed. It has redeployed that. Actually, it's deployed initially for the first time the servlet. Let's see if this is the case. If this is the case, I should be able to run this servlet even in Eclipse or in a browser, and it's supposed to respond with my friendly message. See this? Run as run on server. And it responds. It builds for me a URL with the proper mapping. See this book? Right? Lesson 27 is our context, and this is a mapping for this servlet, and it responded to us. Hello from Find Books. It hit the localhost 8080 where the GlassFish is running, and it found my servlet and it responded. What I will do, I will copy this URL into my browser, right? And no, not here and there. Here and there. And it also responds, right? It says hello from Find Books. That black thing on the bottom, it's an add-on to my Chrome to show the size of the window, size of the browser window. I play with web development, and I need to know what is the current size of my browser window. So it worked. And congratulations, guys. You've written your first servlet, and you deployed it under GlassFish, and you started GlassFish, and you configured GlassFish to start from Eclipse. As a lazy bone, you don't want him to leave Eclipse. And we are done. Homework for you. I would highly recommend you to read a couple of posts from this Tut Plus tutorial. It's about HTTP protocol in general. So next time you are at the party, so at least you can maintain the conversation about HTTP protocols. It's useful information, and read it there. Then do the assignment from try it section, of course, from the textbook, and try to debug it. It's a Java program, right? So you can put a breakpoint in there and you can debug it and see how it goes. And here's a whole bunch of additional materials for you. Just read it. All right, thank you very much for watching this lesson number 14. My name is Yakov Fain. I work for a company called Farata Systems, and see you next time.